Good morning, mathematicians. It is Monday of week 8, and we are starting with some volume. This says, look at the figure below. How many layers does it have? It's really important to remember our layer structures within volume. So let's take a look here. We have one, two, three, four. We are looking at this horizontally, like traditional layers laying on their side. We have four layers. Now it says, what is volume, right? So we already know we have a height of 4. When I take a look here, we have a length of 4. And when I take a look here at the width, we have a width of 3. Let's use the area of the base. 4 times 3 is going to give me, if volume equals the area of the base times the height, I know that the area of the base here is 12 square units, and I'm going to multiply that by the height, right? We're using this formula. Now, volume here is going to equal 48. And what is it? It's 48 centimeters cubed. And certainly my answer line already has the units and the cubed, so I am done. That is my answer to number 1. Let's take a look at our next one. Channing potatum filled 14 sacks of potatoes. Each sack can hold 1/5 of a kilogram. How many total kilograms does he put into the sack? Well, we know that he has 14 sacks. And within those sacks, he is going to put 1/5 of a kilogram. We need to multiply this together in order to get to our answer. We know that we can take our whole number times our numerator, which is 14 times 1 is 14, and our denominator stays the same. So our answer to this question is 14 over 5, or 14/5. And what does that number mean? Well, that means kilograms. That is the total quantity of kilograms that he puts into the 14 sacks. Let's go to our next question, which is definitely an irregular shape. When I look at this, it almost looks like a U, right? We're for sure going to have to divide this up into prisms. And interestingly, we're going to have to divide this into more than two. Because if I take a look, it looks like this side comes out even a little further. So I'm going to make this my prism A. I am going to make, let's see, we could divide it here, or we could divide it here. Let's go ahead, I'm going to divide it here. You may have done that differently, and that's okay. But we should arrive at the same answer. So I'm going to start with the volume of prism A. Volume equals length times width times height. I am looking here and I see my length. My length is 5. I am looking here and I see my width. My width is 2. And my height is just 1 centimeter. So my volume, 5 times 2 is 10, times 1 is 10. So my volume of specifically prism 1, or prism A, is 10 centimeters cubed. Now let's take a look at prism B. Volume equals length times width times height. When I take a look at this, I know that this is 1 centimeter. How much is this quantity? Well, I see this congruent side right here is 2. So I know that 2 plus 1, this particular length is going to be 3. So I'm going to put that in for my length. My width here, let's see, what is the width of this? Well, I know that this had a width of 5, and I know the entire length has a width of 6. So this particular part right here must have a width of 1. Okay, now the height is consistent throughout the entire shape. It is 1. So I have my volume equals 3 times 1 times 1. So my volume is going to equal 3. Okay. Now 3 what? It is 3 centimeters cubed. That is prism B. Now let's take a look at prism C. Volume equals length times width times height. When I take a look, my length here is the longest of all. It is a 6. When I take a look at the width, I'm not sure exactly what this width is. I do know that this entire width was 5, and I know that this much of the quantity was 3, so the missing part here is 2. It must be a width of 2. And remember that the height is consistent throughout the entire shape. It is 1. So I know that the volume of prism C has to be 12 centimeters cubed. Okay, now I have a lot of facts here and a lot of work. Let's zero in on what I need. I see the 12 centimeters cubed for C. I see the 3 centimeters cubed for B, and I see the 10 centimeters cubed for C. 12 plus 3 is 15, and 15 plus 10 is 25. So I know that my answer is 25 centimeters cubed. Okay, that was a good irregular volume question. Certainly, knowing now that those are the same length, I could have gone ahead and done the volume of the entire shape and then subtracted the missing part. That would have worked as well. But certainly, in either case, we're going to arrive at the same answer that we did get. Let's go ahead and take a look at this. The volume of the below cuboid is 5 centimeters cubed. Find the cuboid's height. Well, I know that this times this should give me 5. The entire area should be 5 cubic units. So I know that I'm going to have my length times my width times my height, and together that multiplied together should give me 5. Well, my length was 5, my width is 1. This is the missing dimension, but look, I'm already to 5. So 5 times 1 has to be what that height is, because that's the only thing where if I exchange that for my variable, I'm still going to be at 5. So the cuboid's height has to be just 1 centimeter. One last question for us today. We are looking at this down below, and I see some missing cubes right here. I am asked to find the volume of the entire cube. So how can I do that? There's multiple ways that we can do this. My preferred way for one like this is to go ahead and pretend like it's an entire shape and then just subtract the missing cubes that we can count. I know I have a width of 3. I know I have a length of 4, and I know that I have a height of 3. So the entire shape, if this were a consistent, continuous rectangular prism, a regular rectangular prism, then these would be my dimensions. I would have 12 times 3, or excuse me, 4 times 3 equals 12, and 12 times 3 gives me 36. So if this were complete with no missing cubes, it would be 36. Now, I can subtract the missing cubes. How many cubes are missing in the top layer? There are 2 that are missing in the top layer. I can presume that the same 2 are missing for the middle layer and the same 2 are missing for the bottom layer. That tells me that there are 6 cubes that are missing. So I need to subtract the 6 missing cubes, and when I do that, I get 30. So I know that my answer to this question has to be given in my units cubed. So I'm going to go ahead and write that the entire shape is 30 cubic units. That finishes out weekday Monday.